Hello students, welcome to our engineering graphics video tutorial classes. We are proceeding to our next unit number 5. Unit number 5, its unit name is conversion of views. Conversion of views in the sense what kind of views we have generally. An object can be viewed with the two kinds of views, that is a three-dimensional view and two-dimensional views. What are those two types of views? Three-dimensional view and two-dimensional view. Three-dimensional view, you might be aware that previously we discussed about unit number 4, which is nothing but isometric projection, isometric views. A two-dimensional view of nothing but front view and top view is taken together to form into an isometric view, that is nothing but three-dimensional view. Hope you got this point, right? Previously, whatever the unit numbers like projections of planes, solids, sections of solids, whatever the development of several surfaces, interpenetration of solids, all these units are having a three-dimensional object here and looking into it from the front side and top side, that's nothing but front view and top view. There what happened is conversion of 3D to 2D. Conversion of 3D to 2D. Nothing but 3D is nothing but isometric view, right? 2D is nothing but orthographic view. Conversion of a three-dimensional to two-dimensional view, right? That is our first topic also here. Conversion of isometric views to orthographic views. You know generally three-dimensional means we will have three, nothing but length, breadth and height. I hope you remember this concept of what we discussed earlier. First one, first angles are projection, second angle, third angle and fourth angle. Right here in this, from this location we will be viewing. From here, whatever the location, we have taken this shape, T-shape, front view, whatever this top view, right? That's nothing but converting of a three-dimensional into two-dimensional. Here, two-dimensional views are nothing but there will be maximum three types. That is nothing but front view one, top view, left side view, and right side view. See here, generally these combinations of any two of the three-dimensional length, breadth and height will form these two-dimensional views. Nothing but your front view will cover, from if you look from here, it will cover height and length. Top view, when you are looking from here, it will cover what you call this breadth and length. If you try to view from side, right, from here, if you come towards this side and view from this particular point, it's called as left side view. When you are looking left side view, it covers breadth and height. Same here, right side view also it covers. Now think here, a three-dimensional view, right, of a particular three-dimensional object can be converted into two-dimensional view to simplify for manufacturing purpose, especially in engineering terms. We will take a three-dimensional object and try to convert into two-dimensional so that we can view it more specifically to have its manufacturing or production. That's why this concept of conversion of views, orthographic projection will tell us this conversion of isometric views to orthographic views. Simple, remember, conversion of three-dimensional isometric means three-dimensional into two-dimensional is called nothing but this particular process, isometric views to orthographic views. Same, right? Earlier you have did the same. In the fourth unit, you have converted your two-dimensional to three-dimensional. Conversion of orthographic views to isometric views. Objects, right? I hope you remember, we have solved, for example, a problem, right? A hexagonal prism. The hexagonal prism is having so and so in the front view, having so and so in the top view. We constructed a box and we have drawn 30 degrees towards 30 degrees right side and vertically 90 degrees, constructed a box. That means here, whatever the front view of that hexagon and top view of the hexagon, here it has covered length and height, and here it has covered what we call this length and breadth. We used this and drawn a box, right, like this, height. In this we have made fit our hexagonal prism. That means nothing but conversion of two-dimensional into three-dimensional. Now as per syllabus, we have to solve both kind of problems. Isometric views to orthographic views and orthographic views to isometric views. You know everyone this concept from the beginning onwards, conversions of principle of orthographic projection. first quadrant, second quadrant, third quadrant, fourth quadrant. First angle projection, front view comes above xy, top view comes below xy, below xy line. Same concept we'll be using, right? Nothing more introduction about that. We'll proceed to the problem. See, first and foremost, this is the problem which we have. I hope this will be your exercise number 9, question number 1, right? What is this? Draw, they will ask, draw the front view, top view and left side view of the given figure. Now coming to this is the given figure. I hope this is looking like a three-dimensional object. A three-dimensional object, specifically it will consist of 3 dimensions. As I discussed, 3 dimensions: length, breadth and height. Now if you consider this as a block, right, if you observe from here, it is 30 degrees line, it is 30 degrees line, it is vertical line. 3 faces we have: iso left plane, iso right plane, iso top plane, but they are shaped, they are not in the form of box. Now coming to this problem, first of all, in this block, a arrow mark will be given to you compulsory. For a 3-dimensional object, an arrow mark will be given to you compulsory, which tells us that you have to consider this face as front view face. Which face? This face as front view face. Now when I am looking from this face, I can consider this as length, right? Coming to this as breadth, coming to this as height. Length, breadth and height. Hope you all understand. This is a 3-dimensional object, right? If you simply look, it's something looking like steps, right? Your steps. This is height and this is flat. We have to keep foot here and again height, again foot, again height. And here these will be given dimensions. All dimensions are given. The number specifications are given. When you analyze it as length, breadth and height, try to get the dimensions, right? Total length 104, breadth, total breadth is not given here, but you can compare here. Breadth is 72, height is 48. Inside whatever the details are given, those are having individual definitions. As I explained, when you try to understand it as step, this depth of the step where you keep foot, it's 24. Height of the step is 16, 24, 16. See, like this we have to analyze and we have to draw its front view, top view and side view. As usual, I have drawn this 3-dimensional more than its original dimensions to make you understand a big figure. But the answer figure I am trying to draw very small one. As usual, first of all, you remember you have to draw XY line. XY line, front view, top view. Front view, top view. Front view comes above XY, top view comes below XY. When you are looking from the front side, as we discussed earlier, a 3-dimensional when converted into 2-dimensional, front view will cover length and height. Top view will cover length and breadth. Right? Here, what are front view? We are supposed to start first. Length and height. What are the lines or the details which are having when you look from the front side? See, I would like to take another color to explain you this. 104 is the length. Right now, I am trying to show you. This all part comes as front view because length and height, right? Same way I said it's a step. Flat, whatever the flat, when you are looking from this side, this cannot be considered as height, this can be considered as only length. Now, as part of this 24, if you ignore, this part again comes as front view. Now same way, similarly, if you analysis length and height, length of 104, height of 48 should be completely filled, right? Now how I have to start is, I have to draw a box, right? To initially have to draw a box. See what I am doing in the front view. I am drawing length of 104, right? Whatever this from XY distance, it's your wish. You can 10 to 15 mm you can take. Height, what it is there? It's 48. First of all, I am drawing light box. Now in that, what are the things which you can see is, this is the first L shape which you can see clearly, L shape. So what I am doing is, see to that, start from here, completely 104 length, right? Height, completely 48 height, right? After completing 48 height, come to towards left side, right? It's 24. Now up to 24, I will draw this. Now from 24, this is coming down, right? Up to what length it is coming down? Total height is 48, and you know this one, you don't know these dimensions. Now here, in this conversion of views, analyzing the dimension is very important. See, total height is 48, but the steps, this is 16, this is 16. 16 plus 16, 32. Now here, what's the remaining? 48 minus 32. 48 minus 32, it's again 16. So this will be also a 16. Now what I'm supposed to do is, to come down 16 plus 16, it's 32. I'm coming down for 32. Take your scale, measure, you can draw one by one. Now what are the remaining from this particular point to this point? Entirely it will be closed. Entirely it is closed. Now here if you can see, I'm closing this step, which is about 60 mm. Right? Remaining two steps. Right? This will be like a rectangle. So from here, one more 16, close. One more 16, close. Finally, if you observe and view from that side, that L shape and two cross steps, those are drawn like front view. Now here in this, what you are supposed to do is, right, to give dimensions. Dimensions, you can totally take length and breadth later, no problem. Finally, you can do the dimensions. Finally, this is the front view of this three-dimensional. Is there anything which you have to cover? Means, see, when you are looking from here, length and height, length 104. For this, the parallel line is here, but it is towards inside. It says, right, from here it is height. Length and height, two are there. Length and height, length and height. Length and height are to be drawn here. Very simple. It all depends upon your view and visualization. Now, next thing is, the arrow mark here it is given, so I have considered this as length and height in the front view. Now next, front view here below, top view. Now when you are coming to top view, you know length and breadth will be covered. Length is of what dimension? 104. Breadth is of 72. This is the breadth and this is 72. When you are looking from here, what are the things which you can observe? See, I am trying to change color black. When you are looking from top, there is one more L shape here, this one. And after that, this. Total what? It's a box. It's a box of 104 by 72. See, 104 by 72, how you can trace it here is, to differentiate, I am taking this kind of hatching or shading. Top view, one is this. Second is this. Third is this. Top view, when you are looking from top, this is the L shape, and steps, whatever I have said, step will be always like this, here like this, right? This is foot, where you can see only length, you cannot see height, but here you can see length and height, which is the front view, whereas top view, length and breadth, which you have to consider. So in this step, this is the length and breadth you have to consider. Now when you are coming to here, see, length is common here. So for that purpose, take a light pencil. These are to be drawn with the help of HB pencil. Now try to draw construction lines to bottom for length purpose. Now try to draw a box. Box of what? Length by breadth. Length is 104, breadth is of 72. Now take your HB pencil. Now below XY line, anywhere at 10 mm or 15 mm start. 104 same will get match. 72. Total box. In that box, what are the lines which we have to draw? First of all, this length. See, here it is 72. Now this is towards this side is 24, and now into depth. Out of 72, you can have two 24s. 24 plus 24, 48, and this will be 72 minus 48. 72 minus 48, right? Its same will be 24. So what I am doing is, when try to start here, this is up to 24. Now that 24 line will try to coincide with here. You can draw a light line for your understanding purpose. Projector, we call it as projector. Now from here, draw a line up to what? This is 24. Now from here, try to draw 24. Top first L shape we have drawn neatly. Now second one, 24. Now from here again at a 24 distance, one more line. From again at a distance of 24, one more line. See, now think here, it's almost like mirror. Why? Because the dimension object is like this. When you are looking from this side, it is climbing up. When you are looking from the top, we are climbing down. This is front view and this is top view. Now here we are asked about one more thing: front view, top view, and left side view. Left side view means, see one more. This is front view, top view. From here we have to come to left side and look from this. This particular part is left side view. How I can show you the difference? See, left side view is, see, when you are looking from here, left side, see side view, front view, top view, left side view. No, where to draw it, sir? Actually, I hope you remember. See, when going back to this particular concept, first, second, third, fourth. Here we are supposed to take a three-dimensional object. This one we have discussed earlier. When you are looking from this side, front view will be here plane, here front view, here top view. Actually here it will be the top view. When you rotate, it comes here. Now how about left side view? When you take from this view and coming and look from you, this particular is called as side view. Now this side view has to be projected on back side. Now back side there should be an auxiliary plane. When you try to open, you know this front view and top view which are falling on vertical plane, horizontal plane, vertical plane. This is the first quadrant. When it is falling here and when it is falling top view here, front view, top view, we will try to rotate it 90 degrees and we will try to show it here. That means front view and top view comes below. Now simple, right? Front view, top view like this. Front view, top view. Now same as side view. This is actual front view. Coming to left side, looking from this side gives left side view. It should fall on back side. Nothing but here. Now this is the screen, auxiliary plane, horizontal plane, vertical plane. Now whatever the object is here looking here, we are trying to rotate it like this. Right? And we are trying to rotate it like this. Front view, top view, left side view here, it will fall here. So simply what I mean to say is, the left side view comes right side of the front view. Remember this point, left side view comes right side of the front view. That is nothing but here we are supposed to draw one more reference line x1, y1. Left side view comes right side of the front view. Now think here, when you are looking from here, you can easily, by this hatching, whatever the marks we have done, you can simply look. This step-like view from the side is completely like this, and here this is one more part remaining. I can simply differentiate by what I can say this using one more time black, but I am doing cross. See, side view, it was front view, top view, here left side view. It will be bothering about breadth and height. You know this, breadth and height. Breadth is 72, height is 48. When you are looking from here, this is the breadth, height this is. Now if you look the same way, here we have some more closing part. This also comes under side view. Right? Try to draw box with respect to breadth and height. Breadth is 72, height is 48. Now if you observe, actually you have drawn height here. You have drawn this breadth here. This is length and this is breadth. Now think what you are doing is, from here try to draw lines to match the same height of the front view. To match the same height of front view. Now here with respect to this center point, this is the breadth. Draw projector lines. These are to be tilted. Try to use compass. Try to draw curves like this to match the breadth. Or you can draw 45 degrees lines with the help of protractor. Anything will do. Now try to take them into height. Now this is the box which is formed by taking, I am writing simply here, this is breadth, this is length, this is length and this is height. Now height I have matched, breadth I have matched already with the already drawn front view and top view. So you have to be careful here at this point. You have to draw the side view by matching with the help of front view and top view, height and breadth. Now once it is drawn, see, you know it's outside box completely. Try to draw thick that box. Now when you are looking from this left side, total length and height. What is this height here we discussed as 16. Now here at the height of 16, try to draw this depth, right, 24. That 24 where you can draw, again it can be matched with this line. Try to draw a light line. Try to draw here a light line. From here also you can drag these lines. See, its side view is something easy which you can just draw the light lines. This is the entire box. Right here, what I can do is I just join the points. See, from this particular point, total line height. Total line height I have drawn. Now here again I have to go inside for 24. This will be 24. Now here again I had height of 16. Again 24 inside. Again height. You can see this shape we got. Now friend, when you are looking from here, this is inverted L shape. Already we got this. Try to erase these two things simply like this. Now when you draw them lightly and you draw thick, this finally this is you can get a side view. So understand, this is simple. There is no any method or what you call any remembering construction steps like all other units of the subject. This is, here you have question, all details are here. Only thing you have to analysis is differentiating front view with the help of length and breadth, top view with the length and breadth, side view with the breadth and height. Draw them with respect to XY axis. Draw these projector and construction lines. Finally getting the views. See, you can draw directly this shape and this shape. Front view, down, top view. Here side view. Combination of what you call retrieving the side view from front view and top view. Sir, what are all these construction lines? See, that construction lines will show you that you have drawn as following the particular concept. Right? That's the construction lines. Be careful, you are supposed to draw all light lines and thick lines. Now finishing touch is very important, dimensions. You are supposed to give dimensions correctly. Right? What dimensions we have to show? Front view, length and height. See, I am differentiating with this. Length is total 104, height is 48. So from here, I am erasing this. On the top view where I have convenient, I am showing 104. Height, total height. See, total height, it's 48. Here what I can do is I have breakups. I can draw 48 first, 48, and if I have to show these breakups, right, where I can show is, I can show them in the side view also, right, don't, length and breadth. Now coming to the top view, what you call length and breadth. Here again this length, of 104, breadth of what dimension? 72. Sir, we have just shown total length, total height, total length, total breadth. Now side we will give the details. Now here breadth and height. We have shown breadth here, no need to show again full. Height we have shown, no need to show them. Now split up. See in the breadth what are the things in the top view? 24, 24, 24. Height 16, 16, 16. This is 16, 16, 16. Now think here, try to pull them into parts. Sixteen, 16, 16. Now here, try to draw lines, arrow marks. 24, 24, 24. 72 total. See, finally I have covered length and height, length and breadth. Here instead of breadth and height I have given split ups. See, this already you have just practiced in the classroom once by when Dr. Prabhakar Rao sir came and gave guest lecture. If you have that papers, it will be very easy for you. There we have taken 2D to 3D. Similarly, here 3D to 2D. As per my memory, I remember that there sir discussed about 2D to 3D. Now this is 3D to 2D. Finally, simple, these kinds of objects of the question. In the question paper, these objects will be given like this. You have to analysis for arrow mark to start first, total length, total breadth and total height. After that, try to draw XY line above front view, below top view, and these all hatching for your just understanding purpose. He will ask left side view or right side view. See, for this arrow mark from here, left side view is easy. Whereas if the object is something different, their right side view may be asked. Even they may ask both side views. You can easily analyze, right? If this is the left side view, say you can draw one more x2, y2, draw projections towards the right side and here, and you can easily analyze right side. What will be the right side here? For my concern, it will be a total box. Inside, diminished shape of this. Whatever the thick lines we have drawn, diminished shape will be towards the right side. Hope you all understand. See, simple, don't get more confused. It's a damn sure easy question where question only will use explain about answer, about the solution with the dimensions. Now think here, be careful with the lines. These are all light lines and these are all thick lines. If you are not showing differentiation between light lines and thick lines, you cannot easily identify the answer. That all depends upon how you use pencils of construction pencil and main answer pencil. We'll discuss one more problem on this, conversion of views from isometric to orthographic views. Right? Thank you.